Good afternoon everyone, welcome to part 2 of our build. Today we continue where we left off yesterday. We start with the diode, which is supposed to be over here. Well, it's not exactly just a diode, it's a infrared diode and a opto transistor, if I'm not mistaken. So this is our infrared sensor, which we use for changing layers and some other stuff as well. Yeah, so what we need to do with this thing. So the sensor looks like this. Just recently we switched from a different one. This one is more compact and hopefully it won't require a potentiometer like the other one, because the other one was a little bit more powerful and it was kind of difficult to get it to properly set up, to give it like the proper sensitivity. And it was also misbehaving on white PLA, the infrared will shine through. This one doesn't seem to have this problem. I think it's due to the way it is built. So yeah, so when building Chordie you will have something like this. What you need to do is to just bend the legs as much as you can, so you get something like this. And then over here there is a special opening. So as you can see on the inner side there is a space for the pins. So we go like this. Just need to be careful for one leg in one hole. Okay, and it should go in. You might want to give it a little bit more of a push. Yeah, it should sit in something like this. I hope that is deep enough. From our testing it seemed to be okay. So we end up with this over here. So the two middle ones is the ground, so these two can be connected together. And then looking at it from the top, right? So we have something like this. We have these two openings. This is where the on the right side we have opto transistor, so the outermost right leg is collector. So for this one we need 10K resistor, and on the outer left we have a anode. This is from infrared diode, so we need the 68 ohm on this side. Okay, so looking at it like this, the view is something like that, right? So this is now the same orientation like in the datasheet. So the outermost right is the collector, so over here. So we're gonna put 10K resistor over here, 68 ohm over here, and then we're just gonna connect everything together. And that's it. Looks easy. And yeah, and from this, okay, this resistor needs to be connected to VCC, and then also the same leg needs to be connected to pin B5 over here. Okay, that's something for later. And over here the diode is just simple, just VCC, diode, I mean VCC, resistor and diode. Sounds easy. Let's see how it goes. Yeah, looking at it makes me wonder if I will be able to solder anything when it's sitting inside. It's a little bit tight, maybe. Yeah, but then if I put some tin, it's gonna block it. Okay, so I think maybe for next time I should either expand this thing so we have like a wider opening, Okay, let's see if we can do anything about it. Okay, so for this one, for the middle one, we can use our standard wire. This one, it doesn't have to be too long. Maybe I'll try to bend these two legs together, the one on the inside. Hey there, Electro Wizard. Yes, we are beating Speed Keyboard. That is correct. Oh, thanks for following. Okay, I think we are a little bit in trouble or in a pickle. Maybe if we can try to go something like this, maybe if I push it through, and then maybe I'll be able to just like grab it gently. Let's go like this. Okay, better, but I think this needs some rework. I have to find a better way. Okay, managed to solder. Okay, so these two legs, the middle ones, they need to be hooked up to the ground anywhere on this wire that is going through the center. Maybe I can just pull it to the top, or maybe I can solder it over here. See and we ended up with something like this. Should be okay. Right, so ground is done, but now we have to deal with collector, which is on top, and the diode, which is at the bottom. Okay, let me dig out. Oh, I also got this. I will be building one more extension. I think this bearing will be perfect for our volume encoder. Okay, 68. I think we can trim a little even before we insert. Okay, so 68 goes on the bottom. Okay, seems to be fine. I still need to figure out something about this. I don't know if they are too long now or not. We'll see later. Maybe I can just bend them a little with this thing. Okay, a little bit better now. Yeah, the whole thing is designed by myself. So yeah. Okay, here comes the tricky part. Okay, one more resistor. We still need to get 10K. Over here it's a little bit more difficult because we have this ground coming out. Okay, so from here we need to connect to here. It's gonna be difficult from what I can tell. And maybe to make it easier, because it's gonna be very difficult to try to solder it. Most probably I will melt half of the keyboard. Well, something I didn't foresee, as usual. We have to either make a bigger opening over here, so not worry about directing the legs, just to make a big opening over there, and then we can solder everything in advance and then just push it through. And I get it to work somehow. I think we have to swap a different wire. This one should be easier to solder for this. Okay, this one was easier. Looks like it holds okay. Oh yeah, so the black wire, it's a little bit, it's called like this, wire wrapping wire. I think it's gauge, I think it's 30 or something like that. Not quite sure which one is it. I think it's 30. So basically this is just like a one strand wire which is isolated, and you have one core inside. This one is very easy to solder. I like it a lot, but the issue is that you have to strip every end. And we started yesterday and I wanted to speed run this thing a little, so I decided to go with this one. I've used it in the past. This is enameled wire. This one particular one is 0.2. It's okay. I managed to connect a bunch of switches with it, but now when I look at it, I think it would have been easier to just go with this one, because still it takes a little bit more time trying to melt the solder together with the enamel. And if you go with this, you just strip the end and it's very easy to solder. You just touch it with the soldering iron and it's already done. And with this one, then you have to check with the multimeter if it's really working or not, so it's a little bit more cumbersome. The right side, because this is the left, so I think the right side for a contrast I will try to do with this wire. Let's see how it goes. And over here I've made a little bit of a mistake. I mean, using this wire it's not that bad, because I managed to solder without any issue. But if I wanted to go with this one, that would be rather difficult. So from here, this is collector, right? So we go through here for the canal, we connect over here. Okay, and one more, we need to go from the bottom, this last leg over here, it needs to connect to here. I know, I'm not that good, actually. I can hardly solder, especially SMD. It's always a problem, so don't think that I am so good. This is actually easy to solder, and if you're having trouble, you can always buy. There is like a soldering kit for practice, so you have a lot of different connectors on a PCB, and then you can try yourself. The rule is kind of easy. You just have to touch it with the soldering iron, wait like maybe 2 seconds for whatever you're soldering to heat up, and then you add soldering, then you add the tin, and it should work, technically. After some time it gets better, trust me. Yeah, you're welcome. As you can see, I can't solder it properly. Just made an awful blob. This thing. That's not good. That's not good. Oh well, what can you do? It is what it is. As long as it works, it's fine. Yeah, so you see, it's an approved technique. It's a soldering standard. You see, and this one already came off. This thing just came off. I just soldered it. Okay, this one is a little bit better. I wrapped it around, so I don't think it will desolder. Okay, so next thing, we have to hook it up to VCC, both of these, and the question is how should we proceed, because usually these openings over here are meant for 1mm wire. For this one. So before I used to use this for I2C, one was clock, the other one was data, and then I had VCC on the bottom. But looking at it, we have VCC over here, we have clock and data. So I was thinking maybe it would be easier to just hook up everything, I mean clock and data hook up over here, and maybe pass VCC to the top. Okay, but then, okay, this is left side, so okay, on this side we only have to route from the mini jack. We have to route directly. There is no other I2C element on this side. Okay, so that doesn't really matter that much. Yeah, I think I will stick to the original one. So I will just use one for VCC over here, and then we do I2C on top. And maybe I will go ahead and redesign the bottom because I extended a little bit to compensate for the second wire, but I think that wasn't a good idea. So we can shrink this chin a little, push it up. Although it doesn't look that bad. I will see how it goes. Okay, so the wire. So we need only one. We're gonna put only one on the bottom. Try to straighten it up a little. And just heat it up and push it in. It looks something like this. That should be enough. Okay, so now we can hook up VCC. Okay, maybe I should use a proper red wire for VCC. Although over here, maybe we can get away with this one. Let's try the jewelry one. I just need to route it so that it won't be touching ground, which is next to it. So like from the corner, somewhere over here. Okay. Okay, so it looks something like this. Managed to route it like so. I'm gonna solder it over here and then just cut the remaining part. Okay, so from here, this is our kind of like a bus for VCC. So we can connect every VCC that we need, we can hook up over here. This makes it easier. Otherwise, you would have to solder on one point, which is super difficult. Everything starts to come off if you have more than one. Try to solder like 2 wires and it's a mess. So that's why I came up with this, and it's much better this way. Okay, so let's go. I'm gonna use proper red wire this time around. Previously I used the black one and then I couldn't figure out what is what. So yeah. Let's obey the basic rules. Yes, I can already push 2 wires. I need to push 2 for this pin. This one is for the collector. So one will go to our expander and the other one will go to VCC. But basically for the expander, I think I can go with the black one. So I will know that it's a signal. Yeah, exactly. That's what happened last time. I opened it up and I had no idea which wire is what. So yeah, it's a good practice to just follow at least the most basic stuff. Otherwise, it's get very messy, very fast. Okay, so we're gonna have 2 wires over here. One for the as a data for I2C expander and the other one to VCC. Okay, I think I managed to get both at the same time. Yeah, maybe we can move these maybe over here. Maybe it will be easier, because over here it's a little bit too tight for everything. And then we'll have like a short route. Well, then we have to do something. Okay, something to consider. No approach is perfect. Quick check. Yeah, B5. So our infrared is gonna be B5. I mean the output from the collector. I think this one is too long. You mean this one? It's a wire stripper. I don't even know the name. Ardir. I think I got it from AliExpress. Yeah, it's quite handy. So just pull the wire in. Let's see. Like this. And you just clip it. And you have the wire out. Okay, so one more VCC. So we are done with the collector. We have one wire that goes to I2C and the other one goes to VCC. So this is our pull-up. And then we need to hook up the diode from here, resistor to VCC as well. Yeah, this is one of the best tools. I mean, most handy tools that I am using. Another thing is this, like, you know, to hold stuff. So for example, if you're soldering something, you can just grab it and then you can solder. This is also a must-have in my opinion. I bought it so late that now I'm kind of feel stupid for it that I didn't get it when I was starting. Cool, yeah, so you know how good it is to have. Okay, so we have this part done. Hopefully the diode works. We're gonna find out in 2 days maybe, when we finish everything. Hey, it was a good idea to use those wires, so now it's easy to distinguish between VCC and the data that goes to here. Wait, I think I got it wrong. Yeah, this needs to be on the bottom. My bad. Because otherwise it will be pulled up all the time, because that's the VCC side, so we have to connect to the bottom part. Okay, I think we can move on. Okay, so this thing is done. Next up would be nice to get the encoder over here. Or we can check if it's properly wired. So maybe we can avoid any surprises later on. Okay, let's see. Okay. Okay, looks like everything is okay. So next up, encoder. Okay, this one is kind of too short. How about this one? Okay, this one should be fine. Okay, what I would like to do, I would like to change the wheel, and I would like to use this thing to get it in place, my most recent addition. As long as I don't break anything. Hey buddy, what's up? Nothing, building shit. About to break something. Okay, I didn't break anything. Unbelievable. Oh, hey, Olivia. Okay, we need 4 millimeters of this thing. Very difficult to cut. Most probably I have a wrong tool for the job. have to be mindful because it might jump out, so you have to keep it covered when cutting. Where did I put? Okay, this thing. And I have a different roller for that, this one. Yes, encoder for the keyboard. So to insert it, you have to grab it like this and push it in. You can't do it with bare hands. I hope it's all in, and I also hope it will fit. Okay, we need the bearing as well from this one. Okay, time to push it back in. Okay, seems fine. Okay, and let's see. So this is the black one is the common one, and this will be our B, and this will be our A. Because looking at it like this, if we jump, yeah, so common B and A over here, and if you look at the connection, okay, so B4 will be our B and B3 will be our A. I think it looks good. For a contrast, we have a black encoder. It's so smooth, I like it. Okay, so the black one is the common pin, which is ground, so we're gonna hook it up to this. Then blue is our B4, and yellow one will be our B3. I'm gonna leave this longer. I'm just gonna push those wires over here, save it for later, just in case we need to do something with it later. Oh, many things. What's the purpose? For scrolling, so because the other half will have a pointing device, so you can use it for scrolling up and down. There will be another one on the other side, and then you can scroll left and right. And just like any other scroll, you can zoom in, zoom out, you can reprogram, you can have volume on this one, you can have many other things. You can make it output letters, passwords, anything you want. But usually I use it for scrolling up and down. And the other side is left and right. No, we're not measuring the speed or RPM. I don't think you can measure RPM with this one. It's just like a simple encoder. I think maybe it's possible. I'm not quite sure. Not good with math. Okay, now we have to route these two from here to here. We can either go this way or this way. Okay, so looks like encoder is done. Fully connect over here, B4 and B3 should be okay. So next thing is I think we'll go with the mini jack because okay, on the left side, okay, we still have the encoder, right? Yeah, but we can do mini jack now and then we will go with the encoder. I still haven't decided which one. Most probably we'll start with the simplest one. We'll just go with the mechanical one. I will find it later maybe. Okay, let's go with the mini jack. Okay, I think I will solder first. Okay, okay, so this will be ground, data clock and VCC, last one. So I'll set a bit different than before. Before it wasn't good. It was a mistake. Okay, so for this we need different colors. So we need black for the ground, that is standard. We need red color for VCC, and this is also kind of standard. But then for the data we're gonna use either white or maybe yellow, and clock I usually do with a green wire. Okay, thanks for joining Electro Wizard. See you next time if you can make it. How long does it need to be from here? Okay, so this one needs to be a little bit longer, like this. Yeah, something like this should be fine. Hey Jet Pinky, welcome to the stream. Okay, so as I said, we have this wired up. So this leg is ground. The first one on this side, the yellow one, will be data, then you have a clock, and the last one in this row will be VCC. Okay, so we can push it in over here. Something is off. I think I've made a mistake. And this might be a very bad mistake. I think there is something wrong with the audio jack. Yeah, I don't think this was supposed to be like this. That's a mistake. This shouldn't be round, this should be square. Yeah, exactly. Oops. That's too bad. Okay, what can I do about it now? Okay, one thing is that, well, it kind of almost sits. So we do have some space for the wires if we want to route them, and then we can bend the legs, and that should do the trick. The only thing is that we'll have to adjust the bottom. There's this tiny thingy that is supposed to hold it, this part, so it's not gonna fit. Yeah, it's gonna be sticking out. Oh, such a terrible mistake. How did I miss that? And the other way is you can try to melt it somehow. But that might be not feasible. It's quite a lot of material to melt. Yeah, I think I'll try to get away with it like this. Oh, that is very bad. Okay, maybe we can save it. So the ground already went through. Thank God it's not that tight, so there is still some space. Okay, having it like this, I'll try to bend this a little. Or maybe I will leave it like this for now. We can bend it later. So I'll have to redesign the other half. I have to fix this top because it's not doesn't allow for the plug to be fully seated. How come I missed that? Yeah, and I had it over here, and I didn't even try. This one also doesn't fit. I would have cut it before. Okay, my bad. So the tradition still lives on this channel. Something has to be broken. Okay, so ground we can connect anywhere. Here, wherever we want. Then VCC, yeah, VCC will go like this to the bottom, and then I still have to move I2C. Oh no, I don't have to move it. Okay, so everything will go through here because we don't have to connect anything else to I2C. Okay, so that's one positive thing. Okay, so ground is already attached to the ground wire. So now we have to take care of VCC data. So SDA will go here, and then we have SCL, which is clock. So maybe start with the clock, with the green one, SCL, because it's the furthest away. Okay, so these two done already, clock data. Now we need to take care of VCC. Okay, that went smooth. I'm gonna hold on bending this. It might happen that maybe I can just do some kind of like how to call it? Perturbation? I'm not quite sure if that's the correct word. Just make like a rectangular part a little bit lower to maybe accommodate for this. Although I don't know if it's not too long. Oh, let's see how it goes. Okay, so we are almost done. Encoder. Which one? Which one? Okay, I think I will go with this one. Let's see. Okay, these guys. Okay, I can either use this one. And this one is SMD, or maybe we can go with this one. Okay, this one should be easier to solder. We have long legs for that. Both should fit either way. Just for this one you have to bend the legs a little bit. Oh no, they just broke off. Not an issue. We can still work with that. Well, that is a poor quality. Already broke off everything. I can still solder to that, but yeah, surprised that it's like that. Shouldn't be. These we can chop off. Or maybe I should pull them outwards. Let's take a look. I have this holder for it over here. Yes. Might be okay to just pull them out. Okay, I like this is fine. Can be cut, can be left alone. Okay, so let's take a look on the schematic. So this is our encoder over here. So we have, okay, this will be B, this will be A, and this is for the switch. And of course I have no idea what is what on this one. Let's see. Maybe we can find some explanation. Oh, okay, over here, there it is. Let's add this. Okay, so looking at it from the top, like this, B, C, A. Okay, looks easy. Okay, so like this. So this is for this, it's the common pin is usually in the center. So this will be our ground. Okay, this one will be B and this one will be A. And this is our switch. So for the switch, okay, so we can start. I have some leftover wire, so I think I will use that. Okay, so this is one more time. I wish they marked this. So this is B and this is A. Okay, and one more black. For the common pin. Okay, I think this one should be modified. Because it has a wrong opening. I should have these openings for these screws. I should have a bevel over here to hide the screw, and these are not necessary. So I need to fix that, but I can still solder encoder. Okay, I'm gonna route it this way because we need one piece from the switch needs to be connected to the ground. So I think I will just route it to here. Well, technically I should have... okay, maybe I should modify this a little. Because like we can connect these two, the common pin and one pin from the switch can be soldered together because this is still the ground anyway, but we can't route it through the bottom because on the bottom we have this special holder that will push it up, so then we can use the switch, we can press it like this, otherwise it will just push everything inside. So this is to compensate for the height. I'm just gonna leave it like that. I can solder to some other part. No need to overcomplicate things. Okay, so this one goes to B2, this one goes to B1, this one goes to B0. And we are technically done with the left side. Of course, and one more ground from the switch over here. I need to think about it. Maybe you can find like a good way to minimize this, to somehow connect these two grounds. Maybe. Okay, so this one goes to ground as well. Okay, so this is it. Left side is done. Well, we don't know yet if it works or not. Let's assume it works. We'll only find out after we build the other side, the right half. For now, we still have to check. We still have to fix this part and the mount. So maybe before I go, I can take a look at it. What a mess everywhere. Okay, let's see, what's that? So that's the one that was working for us. And let's see. So I assume the other half is also broken. Oh no, this one is okay. Can you believe it? Yeah, this one, somehow I have different design. For the right side I have the correct one, for the left side I have the wrong one. Cool. That can't get better than that. Yeah, so this one is correct. And let's compare. Yeah, explains everything. Okay, let's take a look. So if I... Oh, that was an easy fix. What is the size? I mean, what's the height from here to the bottom? 879. that is correct. Okay, 8.8. And this one should be... Okay, I have no idea. Is it even... Okay, 90 degrees. Okay, I don't think... let's see, what's the distance from here? Okay, 1.2. Okay, so now it's correct. So this one we can consider fixed, and let's take a look over here. Yeah, this fella. Okay, we don't need this hole. And this one. And this needs to be chamfer 1.2. Okay, anything else? Ah yeah, since we are here already, the diode, right? That was kind of messed up. Can we make it a little bit better, maybe? This part is problematic a little. Well, I could move this, maybe to the top. But then it will be a little bit close to this part. Okay, is there something we can do over here? Okay, maybe, okay, for once, how about we just get rid of it? And do we really need a canal over there? If we open it up, yeah, that is kind of okay. I have this part over here. Oh, that's a little bit... okay, 0.5. So this will still print, so that's fine. If we make like a 2.4, okay, how about okay, from here? To 2.4. This. maybe I will move it to a different component, so then it will be easy to subtract. Let's pull it to here. And now we can go back to base and try to remove this part. Okay. I think this should do. What else can we change? I think we can push this one maybe to have some more space. Let's see, what is the distance? Should be 2.4. Okay, yes, it's 2.4. Well, do we really need more? Maybe not so much, but maybe we can cut it a little bit. Let's say let's get rid of this. And maybe over here, let's make it, okay, 0.5 should be enough. Okay, such a quick fix. Hopefully this way we will have some space over here, so the legs from the diodes will be sticking out over here. So this should give us easier access. Can get rid of this line. We don't need this, we don't need this. Okay, this is still tight, but like over here we have, it will be very easy to route it through here. It's kind of a quick fix, but I think it should be okay. Okay, over here I would like to move this. I would like to move it so it's okay, it's in line with this part. Okay, so I think I would like to move it maybe towards the center. So let's do Alt-Shift-Click like this, and over here. So we have like a mid-plane, and now select this. So we should be in the center right now, and we can move it to here. Whoops. Didn't quite work. Should I also select this part? How about now? Okay, that's odd. Oh, okay, I understand. I forgot this part. These are more important than the top. Okay. Now it's all right. Okay, so we have everything fixed. I think I'm gonna leave it like this. I'm not gonna make it shorter. I think it's okay. It's not sticking out that much, so that is still fine. And on top of that, it's always good to have more space. So this way I can route the wires like this and connect over here to the wire. So it's better than trying to squeeze them, for example, over here. So I'm gonna leave it like that. Were there any other issues? I don't think so. All right. Okay, I think I'm gonna stop on this. I'm gonna leave it for a while. Let it like cool down. Maybe I will come back with some different idea. I still have some time to print it. I can run the print before I go to sleep. It doesn't take this long, so it should be ready tomorrow. Of course. Yeah, right. So this is the left side. So we won't be like redoing the left side, but this part is shared between left and right. So tomorrow, when we will be starting with the right side, so we'll have already this thing over here for us to use. Yeah, and the right side was originally with a pointing device, so it wasn't. It didn't have this issue with the mini jack. I mean, now it's okay for both of them. So yeah, it should be fine. I don't think I had any other issues with it. Everything was, I think, okay. Yeah, these I will leave it like that. They can't be too close, so they have to be in the center. Well, we have this space over here. Yeah, well, basically we are not using this part because when we wire, we go up and we go here. I haven't used this part, so this is a bit of empty space. Maybe we could. Okay, if we move those resistors over here. Okay, we will have VCC close. We will have close to here and then to here. Okay, I think I might use it, but how can we make an opening for a resistor over here? We'll have to put them like this, one next to another. Oh, hey, it's going okay. Found out a huge issue with the mini jack. So it happened that mini jack doesn't fit, at least not as well as it's supposed to. I'd already rectified that, fix it. But of course, you won't be rebuilding the left side. So I hope I can make it work. But now I'm contemplating about moving those two resistors to this spot, because there is unused space over here, and here it gets kind of messy. And it wouldn't be that bad because like we have VCC over here, we have ground over here, like going like this. So we should be able to hook up to the ground if we don't have to actually. We need to hook up to VCC, both of them. And then we have to hook up to here and to here. And one resistor will go to here to the diode. let's see, what are the options over here? Let's do this. Okay, so this is more or less how big of a space we need, at least for one. Let's rotate. Okay, we need at least 0.5 millimeter between both of them. Yeah, indeed, it's quite common. Sometimes it's annoying. You print something, you're pretty much sure it's okay, and then when you go to assembly, usually at the end it turns out you missed something and like the whole thing is broken, and then you have to improvise. Yeah, that's true. Yeah. Usually it's the opposite. Measure once, cut twice. Okay, how can we put it to make it work? Okay, let's save it. Okay, let's try to model the leg. It's 0.25. Nope. Okay, 1 millimeter. It doesn't look like we have enough space. because even if we do it like this, so let's say one wire, so this one needs to go to VCC, and then from this side we have to reach to the diode, so we'll have to go maybe like this. Okay, that would make sense. Then this one needs to go to VCC as well, and then around to I2C and around to here. Okay, so that is something, but how to make them fit? I can push this wall to here. Let's see. Okay, we need some space for the screw over here. Okay, let's see one more thing. Maybe we can make it so that if we press in the resistor, it will be stuck. What is the thickness of this thing? Okay, 2.19. So if you do it like 221, maybe it should be okay. Okay, not sure which one I took out. Need to measure it. Okay, 221. What is the distance from here to here? Okay, 3 millimeters. Yes, I'm gonna move it. Let's make it 221. Like this. And one more holder. 221. Okay, so that is one. That is another one. What's the distance from here to here? Oh, we can technically fit in one more. Okay, I think I know what we can do, because we still might need to do some wiring. Maybe we can do it so that like in the center there will be empty space for the wires. Yeah, okay. So then one of them will be sitting here, the other one over here, and then there will be empty space going through here. Let's see. Okay, so that's... let's move it. It's a little bit oversized, but that's okay. Okay, I think we can give it a shot like that. Oh, we can maybe even copy this, make a bigger opening over here. And I think it might make sense, yeah, to cut this. I don't like it like that. I think I will change it. Something like this. Okay, now I like it better. Okay, so let's do it like this. Let's move this one and this one so that the wall of this one is aligned. Oh my god. Oh, like so. So over here we'll have an opening. Okay. I think I'm gonna leave it like that. I think I should print like a test, because we can do it either like this, depending if it has a good hold on the resistors, and if not, then maybe I can make a wall over here and just make an opening for the resistor wire. Yeah, maybe. Okay, we'll see how it goes. Okay, so maybe let's prepare this thing to try it out. Okay, I think we can do it something like let's drop one surface over here. I mean, that's plane, another surface. Okay, one plane like this. and one over here, and I should be able to clip it. Let's do clip with plane, clip. Okay, clip with plane. Okay, we have to remove union. Okay, let's see if we change direction. Oh, exactly what I needed. Yeah, so this way I can extract only this one piece and I will be able to tell if it fits or not. Then I can do adjustments. Let's see, so if I do it like this, extract geometry, where did it end up? I can't see. Did it even clip? Okay, looks like it doesn't want to clip. Oh, that's perfectly what I want from it. Not quite sure what's wrong. Still nothing. Exactly when I needed this feature, it's not available. Okay, before I forget, let's do this one as well. Okay, that should do it. Okay, let's leave it like this. I think I'm gonna print the whole thing. Alright, so that will be it for today. Tomorrow we will continue with the right side. Everything should be okay, I hope. We have some fixes, hot fixes actually. Yeah, this should maybe help us get through it easier. Okay, I guess that's it for today. Thank you very much for joining, for commenting. I really appreciate that. Come back tomorrow, we will continue our work, and have a good rest. Bye bye.